Hello, we're back with our conductive ink testing. Today we're going to look at the effects of layering multiple layers of ink to see how we can hopefully lower the resistivity, raise the conductivity as we add subsequent layers. What I've put together here is a little test setup. You can see that there are 8 panels here, so we're going to layer things up with 1 through 8 layers of ink. Each panel has 2 patches, so what I've just done here is to put 1.5 milliliters of ink on each patch and then roll it out to an approximate 3-inch by 5-inch patch. The reason that we have 2 patches on each sample is one will be measured as rolled and the second one will be burnished. So as we built up multiple layers, let's say 4, 5, 6 layers, we will have a rolled patch of ink. We will burnish in between each subsequent layer, so we will be able to compare layers 1 through 8 as rolled, and then layers 1 through 8 for each of the 8 panels with burnishing in between each layer. So we've got a fairly controlled experiment here with a fairly constant volume of ink. We did not precisely weigh anything, but hopefully we'll see a trend here and then maybe make some decisions about whether we can use a multiple layered ink method to get some really nice conductivity, some low resistivity to make up a current collector from a multi-layered graphite based ink. From the previous video, I'll reiterate that we're using a 5 micron graphite with a xanthan binder for this ink. So bye for now. We'll be back when we have some data to share. Okay, we're back. We've got our test results from our rolled ink test. So we have 8 different little cards here. Half of the card has been burnished after putting a layer of ink on, and half of it is just as rolled. So in the data that you see here, we've got 2 columns for the 8 different test cards after burnishing, and then without burnishing are just as rolled. A couple things are pretty obvious from the test results. Not surprisingly, everything that's burnished is pretty much better. In this case, 3 to 1 down here, 3 to 1, 2 to 1, or whatever, if we burnish a layer versus just measuring the surface resistivity as rolled. A couple things that I'll point out as we got up in our number of layers. It was a little bit harder to put some of the ink on. Here you can see here we started getting some flaking on the 8th, actually a little bit of crazing, cracking on the actually the 7th layer. But in general, we've got a pretty good trend here showing the blue line where we burnished in between each layer. We took about an hour, in some cases as much as 2 or 3 hours between applying each layer of ink. Initially, for the first, second, third application, an hour was enough to dry it so that we could burnish it. But as the cardstock and the ink built up thicker layers, it took longer to dry, as much as 2 or 3 hours for the later layers. Just looking at the data, pointing out a few things here. It looks like layer 4 was kind of an anomaly here, where the resistivity actually went back up, and I kind of attribute that to the fact that as we burnished each layer, we're really thinning out not only that top layer, but all the layers beneath it, maybe getting a little bit poorer contact depending on how much we burnish and in which directions, and how hard the pressure is that we're applying. In general, after about the third or the fourth layer, you can see the improvements were somewhat minimal after that. Here we started out after the first layer with about a surface resistivity of 40 ohms. That's consistent with what I've seen in the past from this ink recipe. And then we quickly dropped on the third layer to 15, back up to 20, and then kind of, asymptotically tapered off in the 7, 8, 9, 10 range here for the last layer. So very little improvement after that third or fourth layer. The same thing even if it was just as rolled, some small improvements, but nothing dramatic after about the fourth or the fifth layer. Somewhat disappointing is in the fact that I wasn't able to get any of the resistivity down below 5. We got close here, but I think we're going to have to modify our basic ink recipe here, maybe increase the amount of graphite, reduce the ratio of the xanthan gum binder, or maybe the glycerin. There's not a lot of that in there. But we definitely want to target something of ohms per square of less than 5 with a pure graphite, no graphene ink. So I hope this helps you somewhat in developing your conductive ink recipes. Again, we're looking as a goal here to get down in that 1 to 5 range without adding graphene, so that we could use a conductive ink layer as our current collector in these supercapacitor cells. Please, if you have any comments or questions, throw them out there on the YouTube discussion, and we'll see what we can learn together. Thanks for watching, and we'll be back down the road with hopefully some more videos and some more information to share. Bye for now.